This video provides a demonstration of the time-aware shaper of the XL4 TSN protocol stacks. Details can be found in the proceeds of the Automotive Ethernet Congress of 2019, where this demonstration was performed live. In TSN, there are two approaches to shaping traffic. The credit-based shaper is appropriate for infotainment use cases due to its efficiency with streaming data. The time-aware shaper is the subject of this video and is appropriate for control and safety-critical applications due to its ability to guarantee latency. In our demonstration system, we have a talker which will be sending messages to a listener. Both are BeagleBone blackboards. The messaging will be traveling through a two-switch network running TSN protocol stacks from end to end. When the talker transmits, it will also pulse to the scope. When the listener receives, it will pulse to the scope. And we will observe the latency between the transmit and the receive. In this system, we also have a side traffic generator. This is a PC with a 1 gigabit link to switch 1, and it will flood switch 1 with 800 megabits per second of side traffic data so that we may observe the impact of this data load on the latency of the traffic between talker and listener. We are now observing the scope screen as the system is in action. The scope has its time division set at 50 microseconds. In its initial state, the time-aware shaper is off and the side traffic generator is off. So we are observing the basic latency between the talker and the listener over the two-hop network, which is approximately 50 microseconds. Now we will turn the side traffic generator on and see its impact on this latency. When the side traffic is turned on, we see an immediate impact. Latency has become highly variable and reaches up to extreme levels. We will set the marker here to 300 microsecond, and we can see that there is observably high jitter, and the peak latency in fact exceeds the 300 microsecond mark from time to time. In fact, we will see it peak as high as 350 microseconds. Now we will turn the time-aware shaper on, and we have immediate impact with a stable and deterministic latency. We turn the time-aware shaper off again and see once more that we return to an environment with high latency and high jitter. In fact, the latency is effectively unpredictable with the time-aware shaper off. But with the time-aware shaper on, in this configuration, it is highly predictable and never exceeds 100 microseconds. This concludes our demonstration of the time-aware shaper of the XL4 TSN protocol stacks.